Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on water flood. And in this particular video, we'll be talking about water flood induced fracturing. So it's a very interesting topic about the water flood. Okay, so I take the materials in this video from this very interesting paper. Okay, you can see the title, Comprehensive Evaluation of Water Flooding Performance with Induced Fractures in Tight Reservoir, a Field Case. So this is the paper, if I'm not mistaken, from PetroChina researchers. So it's a very, it's a credible researchers, okay? And you can download the paper from the internet and it's relatively short. It's very easy to read, okay, and it's very interesting. And if you read the paper, the authors made a bold statement about water flood-induced fracturing, and you can see the statement here. Whether intentionally or unintentionally, water flooding always takes place under fracturing condition in tight reservoir because of the extremely limited water absorption ability of the formation. Okay, so here it's a very important statement. Whether intentionally or not, water flooding in tight reservoir always takes place under fracturing condition because of the extremely limited water absorption ability of the formation. And this statement is true. I read some papers where the authors saying the same thing, that water flood always takes place, especially in tight reservoir under fracturing condition. Okay, so this is a very important thing to learn for us who currently handling, a water flood asset. So this is very important. If you're handling water flood asset and it is in tight formation, most likely it is in or it is under fracturing condition. And one very easy or very logical surveillance and analysis to do where we have water flood induced fracturing is of course pressure transient analysis. And this is also presented on the paper. And you can see here the authors, conducted two pressure transient analysis. The first one is in March 2014 and the second one is the year after, July 2015. And you can see here, this is the original profile, okay? And the author said that they interpret it as, it's a composite reservoir, okay? Radial composite reservoir. And the year after, when they conducted the well test, when they conducted the pressure transient analysis, this is the profile that they have. And of course, it's very easy, it's very clear that it's fracturing. Okay, you have vertical fractures in your well, and they interpret it as so, as fracturing. So only within 1 year, you can see a big difference. The first one is radial composite, and the next year, you have fracturing in your well, in your injector. Okay, so it's a very logical surveillance. It's a very logical analysis to do if you're handling water flood, especially water flood in tight reservoir. So if right now you're handling water flood asset, especially in tight reservoir, you need to do pressure transient analysis. Okay, maybe most of the time you will get a profile like this. And you are lucky if you have conducted, the pressure transient analysis before the water flood. So you can see the difference, what happened before the water flood and what happened after the water flood. And maybe you can see there is a change across time of your, pressure transient analysis from maybe homogeneous to fracturing, or maybe from radial composite to, to fracturing condition. Okay. And lastly, In the paper, the authors also presented these two, contour maps. The first one is water cut contour map, and the second one, the right map, is the pressure contour map. And you can see here that they can also conclude that they clearly have waterflood-induced fracturing based on the water cut profile and pressure profile. Okay, and you can see high water cut and high pressure is, along this trend, right? You can see it clearly around that directions. And this direction is actually the direction of the maximum horizontal stress. But it's not the main thing in our video today. Maybe I will talk about this in the next video, still about water flood induced fracturing. Okay, so to conclude, I want to reiterate. So whether intentionally or unintentionally, water flooding always takes place under fracturing condition in tight reservoir because of the extremely limited water absorption ability of the formation. So if you're handling a water flood in tight reservoir, most likely you will have water flood induced fracturing. So that's why you need to perform pressure transient analysis to distinguish or to detect the change from the original condition, maybe homogeneous, maybe composite reservoir, to, you know, fracturing condition. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next water flood videos. Thank you.